Hi, I'm Ramesh Maradana, Technical Manager for Electrification and Power Management System for Energy Industry Division within Hub Asia. Today, I'm going to talk to you about ABB Process Power Simulator, which is also known as PPSim. PPSim is a high-fidelity electrical network simulator which provides a realistic experience to your operators and help them to learn on how to avoid power blackouts, perform a black start, perform shutdown operations securely, and handle different critical scenarios effectively. ABB Process Power Simulator has a unique function and goes beyond what a process model vendor typically provides, as it combines a copy of electrical plant control system along with simulated electrical dynamics to provide operator with more live-like experience. Integrating with control system provides a digital twin for your operations. In other words, it's a safe way to train your operator to learn the system which they rely on real-life scenarios. Process Power Simulator has two parts, which are topology editor to build an electrical model, and secondly, instructor workplace to simulate different electrical scenarios. Let us take a look at how to demonstrate building an electrical network using topology editor. ABB Process Power Simulator makes it easy to create an electrical model with a single line diagram. Through a topology editor, you can build your own electrical model by dragging components here and connecting it to electrical network. You can also set a basic and advanced parameter setting of the equipment to replicate your plant behavior and then save the model. Next, you can switch to instructor workplace to simulate plant electrical dynamics for different scenarios. Here in instructor workplace, we can create different scenarios by selecting and controlling motor, circuit breakers, generators. ABB Process Power Simulator dynamically models frequency, voltage, active power and reactive power according to the equipment characteristics and generator response you define in topology editor. To test electrical dynamics, we will run through the scenarios which are most frequent in FPSO operations. Let's begin with starting a generator. To start a generator, click on the generator, make sure it is in local and press on start button. Once you start, generator builds up its voltage and frequency like you see in the screen. Once it reaches rated voltage and frequency, we can close the breaker A15 to connect this generator to network. To close the breaker in A15, we have to go through a synchronization process. To synchronize the A15 to the network, select on sync module, select the breaker we want to close, select the generators we want to synchronize, then click on synchronization module. Start synchronization. Once you press start, synchronization process starts, like increasing, decreasing of frequency with respect to variable and difference. Once it matches, it closes the circuit breaker. Now you can see all the three generators are connected to a network. So the next topic, once we have the three generators in the network, to share the load among them. To initiate the load sharing with the existing generators, we have to give control to remote. Once we give control to remote operator will select the mode of operation. In this case, it is P control and Q control, so that they can equally share the loads in the network. So once the operator sets in P and Q control, new generator starts picking up the load and the existing generators start releasing the loads. Here you can see the trend. The existing generator 1 and 3 is releasing its load and the second generator is picking up its load. And this goes on till they are all equally shared. And then we can control this equal share, unequal share in the remote control system by selecting equal and unequal control. Now you can see all the generators are reached to a level of equal loading in the network. Now once all the three generators are stabilized and sharing the loads equally, let us simulate scenario of starting a DOL motor and verify the generator response. To start a DOL motor, click on this breaker and click on start. Once you start the motor, you can see the response at the starting kick of motor in the HMI. You can see a sharp rise and then later settle. Now let us see how our generators will respond to starting of a VFD motor. To start a VFD motor, click on a VFD, select start, and you can see the response of the generator. It's a smooth ramp, it's not a kick, it's a smooth ramp. After that, we want to test a malfunction of a generator which will lead to a blockout in a normal scenario. But using ABB Process Power Manager, the intention is to avoid such blockouts. So let us simulate a malfunction in network and see how control system responds to it. To initiate a malfunction, click on the generator, go to malfunction tab and click on malfunction. Now you see once you click on malfunction, it triggered for a load shedding. Once the load shedding is triggered, the transient window will pop up where it records the transients of the network, voltage and frequency. You can see a dip in a voltage and frequency and corrected back by other two generators working in the network to a system voltage. Okay. With all relevant information at your fingertips, it's easy to tune protection settings, generator parameter and load shedding priorities. ABB Process Power Simulator provides a realistic way to new operator to familiarize themselves with your system and learn to respond to a critical scenario or a malfunction in a safe manner. Having a digital twin of your actual system, you can simulate your plant operations for the whole life cycle, that is from design to start of production, and helps you to optimize operational performance. For more details, please visit abb.com or contact your nearest ABB sales representatives.